Time for some more kitchen table astronomy with Hampshire College astronomer Dr. Salman Hameed, Mr. Universe, at your Amherst kitchen table. But before we get into what is possibly the biggest discovery in the history of the human experience, one, your father passed away and you went to go to the funeral ceremonies, etc., back in your native Pakistan. So we, on behalf of the fabulous 413, extend our condolences to you and your family.
Well, thank you very much. I mean, he was 95 and he lived a good life, and it was good to go over there. And I was there 2 months back to Pakistan, and I got to see him recently. But yes, thank you very much. Thank you.
The other thing is you are a board member of Amherst Cinema, and we talk a lot about film and television. The Emmys were last night. We're both Severance fans. Severance was robbed.
Yes, but Severance is complicated. Severance. I mean, I'm actually glad that it was nominated for so many awards, but also it did get 2 of the actors and actress awards, and those were actually fantastic in both cases.
And Helly won.
That's exactly right. So I think, it would have been great if it would have won, but I think it was also a little. I'm not sure, whether it would be fully popular in that context. And I think it was good.
And The Pit, which did win a lot of them, was good. I haven't seen that Seth Rogen show at all, but I want to watch that one now that I've seen him win all these awards. I will say, my family does a ballot poll to see. Pax, my 12-year-old, got 4 out of 26 of the awards correct. I got 9 out of 26 of the awards correct. And my 18-year-old film student who's at Clark University got 20 of the 26 correct.
Doesn't he beat you always in the Oscars as well?
Not only by a little.
Yeah.
By a ridiculous amount. And he's not cheating. Anyway, back to the potentially the most important discovery in the history of humanity. I was listening while we were doing the Fabulous 413 to the NPR newscast last week, and there was a story in NPR National saying that scientists think they found the signature of life on a rock from Mars. I text you immediately and I'm like, is this the big one? Is this the big one?
Well, possibly.
I hate that.
No, okay, so this is something, there is a rock on Mars, so there is a Perseverance rover that is roving on Mars, and it is analyzing samples. Just as a backdrop, this rover landed there in February of 2021, and it went there in a crater, Jezero crater, and this is a place where we are, and by we I mean scientists are pretty sure that there used to be a lake over there. So there was standing water there, and there was a river that flowed into this crater where it would fill up, and there is a river delta. And we knew that there are interesting minerals over there. And so this rover has been spending last couple of years over there, and now it is more in the Delta region. And it found a rock, which is called Chiava Falls. It's just the name of the rock that scientists gave. But it had some interesting features. So this particular rock, just as size-wise, it's about 3 by 2 feet wide. Okay. So it's a reasonably small rock. And we talked about it, Monte, about a little over a year ago, where there were initial results that suggested, well, what the way they framed it was there may be signs of life.
I remember that. Signs of life.
Right. And so what they have done further analysis, and here is the key challenge that comes in. So you can find signatures that on Earth are definitely made by microbes, for example, right? But when you are looking on Mars, the same rock, same type of signatures, and you go like, well, on Earth, these are usually leftover signatures from microbes, but are there other processes that could mimic the same thing other than microbes? Because on Mars, we have no other evidence for life otherwise.
So this is what is both beautiful about science and extremely frustrating. If we found this very same rock on Earth, we would say, clearly, this is evidence of ancient life. But because it's on Mars, and because this is how the scientific method works, they're trying to say, we need to disprove every single other thing we could possibly imagine or think of before we say this is signs of life. But if it were an Earth rock, it would be signs of life.
Right, because there is a lot of other life here on Earth. So you can actually guess from that, like, that, okay, well, here, the simpler explanation is because you are surrounded by life, because life pervades every single thing, that, well, this probably was signature of past life on Earth because of microbes are present everywhere. But the same, you cannot extend the same kind of reasoning exactly on Mars, but because you have to rule out all of the things because you are not surrounded by life, right? So, okay, so let me just give you a little bit of a context of what happened in this particular case. So there is a rock that I mentioned, and it has two minerals in particular. So the scientists named them poppy seeds. These are sort of like small signatures. They're not actually poppy.
And those we have signs of life.
Right, exactly. And that contains a mineral called vivianite. And this is iron phosphate. And then there are, in the same rock, there are also some patterns which are called leopard spots. Again, there are no leopards on Mars. Exactly. And these are sort of like dark rings and that contain sort of like vivianite, but surrounding sort of like off-white centers that include another iron-based mineral called greigite. And this is iron sulfide. Okay, now, these things on Earth are usually the leftovers after the microbes have used organic material, then they excrete out, in some sense, if you think about these minerals. And so on.
So this is Martian poop we're looking at. The evidence of life is Martian poop.
Microbial poop. So these things here are in sedimentary deposits in freshwater lakes here or in rivers on Earth, right? So very similar type of thing. Now, once you find on Mars, the question is that a few billion years ago, so this is not evidence for life today. This is a rock that has, in some sense, like, Martian poop signs, like, from the past. So a few billion years ago, we know that water flowed over there. We know that there was a lake over there as well. And you are seeing these signs. Now, on Earth, today, when you see these things, you know that there is a freshwater lake or a river, and you have these signs of microbes leaving behind these signatures.
Even if you're looking at rocks from a billion years ago on Earth, we would say, yes, this is what happened here a billion years ago. It was life. It was a feeding frenzy of microbes, and they pooped here, and here's the ancient evidence.
So a little over a year ago, when this rock was found, people were like, whoa, this is actually a pretty interesting thing because it passes a lot of the tests that we think life may have, the signatures of life may be like. But the problem was that the same kind of things can be produced inorganic or without life as well. But at that time, they didn't know whether they can rule out those things or not. In particular, you could form these things in extremely hot environments, so over 250 degrees Fahrenheit, for example. If there was volcanic eruptions or volcanism, or highly acidic environment where you won't find life, but you can actually create these things. So that was still an option, and that was the reason why they couldn't really rule out. But now it looks like, from looking at the things around this rock and this rock as well, that the surrounding area did not, or the sediments did not experience really high temperatures.
So they ruled out these other things?
Or acidic environment. Ruled out meaning, so this is the new results that have come out. They have looked at, and they're like, at least it doesn't look like that these rocks were in high temperature environments or highly acidic environments. So as you can see, this is the reason why it was on in the front section of the New York Times or on NPR, because they're trying to rule out everything other than life. And we are one step closer to that.
What else is there left to rule out? At what point do we say this is it? This is the big one. What more could we possibly be looking for?
Well, I'm going to give you a cop-out answer.
Okay, good.
And because all of these stories have this answer, and that takes you into a political realm. And that is that, in theory, you need more, if you were analyzing this rock, for example, here on Earth, you have these amazing instruments, you have electron microscope, you have all of these things that you can actually really put these things through and figure this out. But you are, I mean, what needs to be appreciated is that we are doing all of this stuff on another planet, right? Like, which even just communication wise, it takes 20 minutes at least to sort of communicate with the rover over there.
Because we're 20 light minutes away from Mars.
At least, yes. And so it is difficult to do these experiments because the Perseverance rover, with all of its amazing capabilities, has limited instrumentation that it can analyze. So one of the things that Perseverance rover has been doing, and has done that with this particular rock as well, is to actually take a small sample and put it over there, leave it for a future Mars sample return mission. So this was a plan that this Perseverance rover is going to pick up these samples and from various places, leave them over there for a future mission. It was expected maybe perhaps in 2030 that's going to go over there, pick up these vials of material and actually bring them back to Earth. I mean, just think about it.
30?
But just think about this concept. I mean, isn't it amazing sort of to actually bring it back? And of course, this rock is crucial, and so it has taken the sample out, and it's waiting for the mission to come back and get it. Well, okay, so this is the second part that comes in. Partly that Mars sample return mission expenses had gotten already pretty high. I mean, I think it was like over $11 billion. Again, if you are comparing it with military aspects or any sort of military plane or missiles and things like that, not that much, but yes, it had gotten quite a bit more. So they were trying to figure out how to reduce it, how to go through with ways that it could still happen. But now, with the current administration, it is not on the docket. It's not going to be right now being funded. And they are saying that, well, we'll do something, but it's unclear what. And also, there is a lot of emphasis on away from these robotic missions, which are mostly purely science-based in some sense, to more of sort of humans.
Well, let's send humans up there, fine. Then we can retrieve them right then and then bring them back.
Sure, but as you can
human hands.
But as you can imagine how long it's going to take, not to mention that there are all these issues personally. I mean, before we send humans, we have to make sure that there is no microbial life on Mars today, which we don't know, because otherwise our microbes are going to take over and so on and so forth. So there are whole other things, but for the time being, it doesn't look like that there's going to be a Mars sample return. But this is actually a great rationale for bringing the samples back from there too, so that we can analyze. That said, China does have a plan to send a sample return mission. I don't think there is there are plans that they can pick up this sample, the ones that have been done by NASA, especially because I think a few days ago, a new directive has been passed that no Chinese nationals can work anywhere in NASA at all, which used to be, so again, they used to actually work, but now just a few days ago, they've just barred all Chinese nationals from working on any place in NASA. But that could be a great way of cooperation. Of course, at the height of the Cold War, there was this Apollo-Soyuz docking that is famous. I think this is 50 years of that. So there can still be cooperation, but I don't know with our current tenor and with our current atmosphere that is going to take place. All that said, I still hold hope that even on Mars, even with Perseverance rover, maybe we will find some more stronger evidence for life. But one of the interesting things here, apart from everything else, is that this rock is part of the youngest sedimentary layer in the region. And even though it's still a few billion years ago, but if it turns out to be the case that there is life there, then it means that life actually, when it developed on Mars, it actually stayed there for a longer time than previously expected. And of course, if that is the case, then we may find other places as well where there may be life. Now,
if we dig deeper, we might find even better, more and better evidence of life.
And also, there are other places as well. They have rovers that have gone to other places, but none of them have found any signatures like this. But This is the only rover that has gone to a place which is like a river delta and this crater which we know was in standing water. So Mars is diverse. Mars has different environments, and so maybe the next rover that goes, if our science continues, then it can go to a place something like this, and we will have a better idea to know what to look for. Now, before I go, I do have to bring up one thing.
Oh dear.
This is actually a wonderful example of how science is done. I mean, they are trying to rule out the most sensational claim, because that's, again, that goes back to Carl Sagan. Extraordinary claims require extraordinary evidence, and this is certainly is an extraordinary claim. But there is a comet, interstellar comet also around, which is the third body, like, that is from some other place that is passing by our solar system. And again, the astronomer Avi Loeb claimed that, like, first he claimed that it's probably an alien spacecraft or alien technology and things like that. And now, by the way, we also know that that particular comet has developed a tail as well. So no, it is behaving like a comet. But that's a different way of approaching these things, that you first believe that this is the most sensational thing, and then you get all the attention, and then you go, maybe not. And most scientists disagree with that kind of thinking, but Avi Loeb himself has said, like, that, well, that's how to get public attention. And I'm not sure whether that does overall service to the public or not, but he believes it does. That you first say there is life, and then later on, show like, no, actually it was a false alarm.
I think in the era of fake news and misinformation and AI and not knowing what's what, that is a very dangerous thing for a Harvard astrophysicist like Avi Loeb to do. So
can I say one other thing? By the way, this is another thing that I find, like, and this is actually a good warning sign, that whenever that story of Avi Loeb comes in, people actually always mention Harvard behind him.
Yeah.
Right, because Harvard astronomer.
These books
Exactly. And so
I want a Hampshire astronomer.
no, but the thing is, you may not need to do that. If actually the actual story is actually well grounded, then you don't have to say. You just say, scientists have found that.
Yeah.
But if you say, Harvard astronomer has found that, run immediately.